test the continuity of a function. We came across the type of functions like this before. They're called piecewise or hybrid functions. And we know that the function is defined for x is greater than or equal to 2, that when we have a domain, in that domain, that the function is going to be equal to 3, and when x is less than 2, we've got to have, or the function will be equal to 1. And we're asked to determine whether this function is continuous at x equals 2. So there are 3 steps, 3 tests if you like. The first one, now it's at x equals 2, so f of 2 exists is my first test, and by the definition up here of what the function looks like, when x is equal to 2, the function is equal to 3. So f of 2 equals 3, so it has passed the first test. Alright, so f of 2 does exist, and when when x is equal to 2, the function is equal to 3, because of that greater than or equal to sign there. The second test is that the limit as x approaches 2 of f of x exists. So we've got to test that. Does that indeed, is that true? So we can see that the limit as x approaches 2 from the negative side, so when x is less than 2, the function's getting close, it's equal to 1, so it's going 1, 1, 1, 1, 1. So f of x will be equal to 1. So as we approach 2, when x is less than 2, the function's going to be equal to 1. If we approach 2 from the positive side, the limit as x approaches 2 from the positive side of f of x, the function is equal to 3. Now, because we've got 2 different values when we're going either side there, there is no limit. There is no limit, because these two have to be the same value as it approaches 2 from either side. So we don't need to go. The third step is that the limit as x approaches 2 of f of x equals f of 2. So we don't have to worry about that, because this one here has already failed. So we can now say, therefore, function is discontinuous at x equals 2. Once again, graphically, what does it look like? So for all values x less than 2, so if we've got 2 here, the function is equal to 1. So, might have to just draw a bit straighter there. And then for 2 and more, it'll be equal to 3. So it goes on. So, some ways, some books and some school of thought is that if it includes the value, you actually put a circle around it and colour it in. And this one here will have an open circle to say that it does not include 2, but all values less than 2. When it's coloured in, it includes 2 and goes on there. So certainly f of 2 exists, and it's equal to 3. But the limit certainly, and you can certainly see that there is a gap in the function when we do it graphically. But they are the 3 tests that will allow you to determine whether we have continuity or discontinuity for a function.